Hi, I'm George Woodbury from the College of the Sequoias in Visalia, California, and in this video we're going to tie it all together in terms of graphing. We're going to talk about horizontal, vertical stretches and shrinks, horizontal and vertical shifts, and reflections about axes all together. So we've got a few problems to work on. The first one is the graph of f of x equals 2 times the absolute value of x minus 4, then minus 3 from there. So the first thing that I think about is the general shape. And so this is an absolute value function. It's a V-shaped graph. The tip of the V is at the origin. Now again, this is just for the absolute value of x. But we've got a few things being applied here. First, x minus 4 inside the absolute value signs tells me that h is equal to 4. And that means that this graph is being shifted 4 to the right. The 3 that's being subtracted outside of this absolute value is our value of k. And because it's a negative, that means that we're moving down 3 units. The only other thing we have to worry about is 2. This on the outside is a vertical stretch by a factor of 2. So the first thing I want to make sure I know about are any times where a graph's going to be reflected vertically or horizontally, and we don't have that here. We don't have a negative in front of the x in the absolute value. We don't have a negative on the outside of the function either. So no worries about reflection here. I'm going to move the point 0, 0 to a point at hk. And in this example, hk is 4, negative 3. So over 4, down 3. I'm going to put a point right there. That is the bottom of my V. Now I know that the graph is still opening upward because there were no reflections about any axis. The only thing I've got to worry about is normally this function moves up 1 unit, up 1 unit over. But because I've got this stretch factor of 2, it's actually going to take jumps of 2 each time it moves out. So up 2 over 1, up 2 over 1, up 2, 1 to the left, up 2, 1 to the left, and so on. There is a quick sketch of the graph. 2 times the absolute value of x minus 4 minus 3. Basically, I took the main function, which would have been here. I picked it up off the graph. I moved it 4 to the right, down 3, and then I stretched it up by a factor of 2. In the next one, we have a negative sign out in front of the square root. So this negative sign means that we're going to reflect about the x-axis. So what I want you to think of, the square root function, which we know the basic graph of, starting at 0, 0, up and to the right like that. This one's going to go down to the right instead. We're going to rotate, reflect it about that horizontal line. Now I need to know what my h and k are. There's no stretch factor or shrink factor in front of the x or the function, so all I really need to know is h and k. My value of h is negative 2, because this is really, again, the same as x minus negative 2, so that's a shift of 2 to the left. My value of k is 5. That's a shift of 5 upwards. So again, hk is going to be at negative 2, 5. That's where this graph is going to start. So negative 2, 5 would be here. Now I would draw the basic graph up like that. But this one is going to be flipped over. So the next point is going to be down here, and down here. Like that. Now, it's tough for me to actually draw it really well on the iPad that way, but that's the way that that one's going to look. It's going to start at -2, 5, and then it's going to go down to the right. One last one. This one's got a little of everything. So this basic function is the function x squared, and I know x squared is a parabola that turns around at 0, 0 when it's just x squared. What are we applying to it? The negative tells us to flip it over the x-axis, so this one's actually going to open downward. There's a vertical shrink applied to it then of half, so every point's half as high as it used to be. My value of h is 4. That's what's being subtracted from x inside the parentheses. And my value of k is 6. So 0, 0 is going to move to 4, 6. We're going to take the parabola and make it open downward. And then we're going to shrink it by a factor of 1/2. So I think the best place to go is to 4, 6, our value of h and k, and put that on the graph. Now, remember the pattern was 0, 0, 1, 1, and -1, 1. So those were down 1, out 1. But for this function, because of the 1/2 in front of it, it's going to be down 1/2, out 1. So down half, out 1, down half, out 1. And then the next point was at 2, 4, and -2, 4. So half of those 4s are going to be 2. So down 2 from the turning point and out 2, something like that. And there is our graph. Without the 1/2, let me switch it to red. Without the 1/2, the points would have been here instead. But they got pulled halfway back to that turning point, which we call the vertex. All right, so there's the graph of that function. It takes a lot of practice to get used to these. Try to develop some kind of systematic way to go about them. Figure out HK. Figure out whether it's going up or down from there. Figure out if there's some kind of stretch being applied to it. And then try to put points from HK at that spot. All right, that's it for this one. I will see you in the next section.